The land we bought in the Amazon came with these large clear-cuts covered in invasive cow pastures, and in all honesty, we thought that the surrounding jungle would reconquer all of this rather quickly once we let it do its thing. But the reality has been that the grass has continued to dominate. It is very, very persistent. It even burned down fully at some point, only to come back twice as strong, which is why we have now decided to take some active measures. These are our tree islands and strips, the humble beginnings of a new experimental forest. Each cluster here is a starting point of hope and recovery, and as they grow and spread, we hope that they will reconnect the canopy on our lands to reclaim the invasive grass pastures so that a thriving and biodiverse rainforest can stand here once more. And in this video today, we want to show you our never-ending battle with the grass and why we needed to replant the trees here, how we're using our land as a rainforest rewilding lab to help refine restoration solutions, and show you the results of a full year worth of growth and progress. Welcome back to the Amazon rainforest.
We've been thinking about what to do about this non-native cow pasture grass for a while, and we were kind of hoping that the jungle would just take over. But it's been over 2 years now, and you can see the grass is still growing strong. So today we are starting a project to push back this non-native grass and let the forest grow back on our land.
But first, let's take a step back to look at the broader context of the problem. Our land sits here, on the edge of the Yasuni National Park, where the three distinct ecological systems of the Andes, the Amazon, and the Equator meet. This special combination has created a biological wonderland, even by Amazonian standards. In a single hectare of Yasuni rainforest, there can be more tree species than in entire countries. Life here just stacks itself on layers and layers, from the soil to the streams, the roots, the trunks, the canopy, and the sky, each packed with organisms taking advantage of the unique conditions and ultimately creating the most biodiverse ecosystem on this planet. But even here, the forest is not inexhaustible. When it is cut down for oil extraction, mining, or agriculture, we can start down a path that studies warn us could get the rainforest to a tipping point that triggers the collapse of the forest's water cycle, leading to tree dieback and potentially turning this ecosystem into a degraded savanna-like state. And this is a really complex problem that we won't pretend to have the solution to, but there's still something we can do, which is to show how the rainforest can be recovered for a time when minds change, and this needs to be done at scale.
We have around 5 different species of grass growing here, and as you can see, the grass is really dense and really tall. It's taller than me, so it essentially doesn't allow much else to grow here. Basically, it's really hard for any seed to make it down to the soil, and even if it does, it will struggle to grow here among this grass shaded over. And also, a lot of the trees in the Amazon are dispersed by animals, and this is not a very inviting environment for these seed dispersers. So this is why it's actually very difficult to get rid of these non-native grasses.
This has not been the case everywhere in our land. You see, the previous owner started a small and certainly unintended experiment that we can now take advantage of. He left us with clear-cuts, Manila hemp plantations, cacao plantations, and the pastures, all of them abandoned. So now we can compare how they regenerate. The clear-cuts are regenerating fast, the soil remains undisturbed, and the seed bank is intact. It's now a dense, young secondary forest with fast-growing pioneer species. We haven't done a full inventory, but we mainly found balsa and cecropia, showing good natural recovery. The Manila plantations show a similar pattern. They were quickly abandoned and never maintained, and felled trees were left in place, so the soil wasn't disturbed either. No intervention is needed here. In the cacao plantations, regeneration is slower due to grasses from nearby pastures invading and outcompeting native seedlings, but native trees are growing around cacao trees where there's shade. Succession is ongoing, though slower, and we'll monitor whether enrichment planting is needed, which leaves the cow pastures as the one place we have to intervene to break the grass's stranglehold on this place and kickstart natural regeneration.
So there are a few trees that have managed to fight their way through the grass, but unfortunately even those burned down in a fire. But anyways, under these conditions, it would take very, very long time for the forest to regenerate naturally.
The fire was started by a fallen power line, and thankfully it was contained to the grassy areas, but it highlights the risk that these pastures pose to our base here and also to nearby residents. But our problems here run even deeper.
So the soil on this pasture is probably quite poor, and also the seed bank is probably quite depleted. And the grasses are actually adapted for their seeds to survive quite a long time in the soil, as opposed to the native trees, which have quite big seeds and they don't survive for so long in these soils. And the grasses are also adapted to fire, which the native trees are not. So here the grass has an upper hand, and that's why we want to tip the scales a little bit and help out the native trees.
When looking for the right solution, we have to place ourselves on a spectrum that goes from the cheap approach of doing nothing and letting natural regeneration take over, all the way to the expensive approach of planting the whole site. On this end, the literature shows that even after more than 2 decades of natural regeneration, cow pastures similar to ours led to poorer forests, often dominated by a single genus, which, compared to the potential 670 species in a hectare that are possible here in the Yasuni, would be very poor indeed. So it's cheap but suboptimal in the short to medium term. Then, on this other end of the spectrum, we have the large cost of replanting the whole site and cutting the grass periodically until the trees can dominate. It leads to a solid outcome, for sure, but it might be wasteful in terms of resources, and it is certainly less scalable for others who want to do this in other places in the future, which is why we ended up in the middle here, by selecting an intervention called applied nucleation, or, an easier term, the tree islands method. This is an approach that combines small-scale tree planting and natural succession by first planting clusters of different trees, which over time will attract seed-dispersing birds and mammals, which in turn will help the forest expand and connect to the primary forest further out. And as a final check, we ran our idea past Dr. Karen Hall, a leading researcher of this method, and ended up settling on a paired plot trial that looks something like this. We have areas 1, 2, and 3, which then get divided into an islands plot and a strips plot to help us identify which of these two applied nucleation techniques works best. Both of these use 3 meters between the trees, the squares being 12 by 12, and the strips running the length of each plot at 9 meters wide, except for area 1, where they are 12 meters wide, so that we can plant all the trees that we need. The key thing is that the total trees per hectare is the same in all of these plots to make them comparable. Then, in terms of the trees, we ended up selecting 8 species. These are neatly distributed by their successional role, from pioneer to early, mid, and then late successional, as well as the size of the fruit they produce, from pods to berries and then larger fruits, and the time they take to bear fruit, from 2 to 3 years for the guava, all the way to potentially 10 plus years for the sandy tree. And this nice mix of tree species allows us to support all stages of succession, but there is still a bigger emphasis on pioneers at this stage, for obvious reasons.
So this is a guava, and it is a nitrogen-fixing species. And on its roots, it has these white dots or these white balls with the symbiotic nitrogen-fixing bacteria. So we are planting 2 species that are nitrogen-fixing in the mix. They make up over half of the plants that we are planting. And the presence of these species will basically help all the other trees grow as well, because they will enrich the soil in nitrogen.
So, to plant these trees, we make the holes a little wider to give the roots more space and to loosen the soil so they can establish more easily. And after adding a bit of fertilizer and loosening the roots from the compact shape that they acquired during their time at the nursery, we can plant them in. And for larger trees, we make a small mound in the hole so the roots can spread out more naturally. As usual, we hired people from our community to come and work on this planting and the subsequent management, and this has been something that Freddie has made sure to happen whenever possible to bring rewilding related money into the local economy.
The people here have been absolutely wonderful, and they are such a great support in this endeavor. So the men have it completely under control. They are going, measuring, digging the holes, and then the ladies go behind with the trees and plant. So we are in a really good flow already after a few days.
In total, we spent $7,661 to source, transport, and plant 1,243 trees on 3.34 hectares of pasture to get our trial underway. This is a bit more expensive than we usually like to plant trees at because of how difficult it is to source the necessary species and then transport the plants to this remote location and, of course, cut all the grass in order to plant them, which is why we're so keen to find cost-effective planting methodologies. And I think this project is a great example of something important we have at Mossy Earth, which is a culture of not only using relevant evidence for planning, but also generating evidence as a result of our projects. And moving forward, we want to take this even further by publishing open source rewilding protocols that everyone can use to run their own projects, because we think this is an easy and cost-effective way of increasing the impact we make from the money we receive from our members. And if you're not yet a member, well, you're missing out. We do all kinds of amazing rewilding projects in a wide diversity of ecosystems. We have our own teams in 4 countries tackling big landscape level projects, and we also collaborate with partners from the cold wetlands of Iceland to the deserts of Benin and everything in between. The membership is really cheap to join, but together all of us can do really big stuff, such as buying this bit of land in the Amazon when Freddie asked us to, and then using it as a living rainforest rewilding lab. So if that sounds like something for you, then please consider joining us at mossy.earth. The link is in the description, or you can scan this QR code here. Now, since we started this trial, we also hired Leah, a new team member here in Ecuador, and I asked Lily, one of our Scottish biologists, to help film some of the videos this year. So she joined the Wilder Yasuni team to do the monitoring.
So we are individually going to each tree, noticing how they are doing, seeing their leaves, seeing if they have dry leaves or if they are growing well, and taking notes of them, comparing the number of the ones that we planted and which one survived.
From our monitoring of Area 1, which is the one complete monitoring I have for you at the moment, we had a survival rate of 71%, but with a clear difference between the various species, with the guava, acai, and caimito all doing rather well, with survival rates above 90%, and the warango doing rather poorly at only 30%, and even the ones that did survive are not looking that good.
Warango is also they usually grow in the open areas, but here it's not doing well. This one can grow 30 meters high, but it's not doing well in this island.
We think the main issue with the warango has been the small size of the plants we got from the nursery. They were probably too young to plant at the point we got them. And when you compare the results after 1 year, you know, the puny tree Freddie just showed you, I mean, when you compare that with species like the guava, it becomes really clear how important it is to plant the right species and in the right conditions.
After our first morning of monitoring, we have a clear winner of the tree which is growing the best. It's the guava, this guy behind me. It's pollinated by hummingbirds, bees, ants, all sorts of things, and it also fixes nitrogen, which might be why it's doing a wee bit better than the others.
It is also nice to see that by maintaining these squares and strips, we are also supporting the natural regeneration of trees which were already establishing in the pasture, and this helps to further improve the conditions for our trees.
So, for example, this big one that we have here, that one was really small when we started planting the trees that you can see around, and it grew so fast because it is like a pioneer species. So as you can see, it is really big right now, and it provides shades to the trees that we planted nearby, and that really seems to be giving them the chance to survive. There are other squares that also have even more trees growing naturally, that are showing us that it might be a good strategy that we use the trees naturally growing to plant our native trees around and maybe give them a push to grow easier and healthier.
Now, our goal here is not to recreate the original species composition of the forest through planting. Instead, we want to restore the ecological processes that help the forest follow its own unique successional path and get it unstuck from the degradation loop. There's a very clear distinction here. The islands are simply a nudge in the right direction to help fix nitrogen, offer shade, and spread seeds. And as such, our target for the first 5 to 7 years is simply to reach a canopy cover of 70%. That is the key goal of this project and what we will measure our success against.
While the grass is maintained in the tree islands, you can see, as soon as I turn, where we're not cutting the grass, it's so tall, taller than me, and there's absolutely no way that trees could grow in these kind of conditions.
We're now cutting the grass every 2 months and considering giving it a taste of its own medicine by covering it in tarp in another small experiment. But it isn't all just a fruitless battle against the grass. Some of the ants have started taking advantage of our guava, and crucially, we also got some of our first winged visitors.
So there's an Annie right here in one of our plots. It is such a good insight to have that there are birds using the trees that are growing as a place to have a little rest, maybe take some feathers out. These birds could bring seeds from around the forest to put them here, and the seeds can start sprouting, which is just the process that we want to have of regeneration and natural succession. And it is just really exciting to see it happening and know that our plots are already being visited by birds.
It is really great to see nature starting to take advantage of our little experiment. These birds are doing exactly what we want them to do. Just sit there and shit out some lovely seeds from the nearby forest. And I really look forward to seeing the progress in the coming years. And if you want to help us here at this project in the Amazon and at all our other rewilding projects, then please consider becoming a member at mossy.earth. It is truly the only thing that makes our work possible. Until next time. Cheers!